All right, GM, everyone. Good morning. Happy Thursday. Happy beginning of October. Super excited to have you guys here. We are officially kicking off Dreamathon with Paul from Somnia. Again, this is going to be a killer cohort that is coming through. The quality of the projects is absolutely badass. So we're super excited to get underway. I'm not going to take too much time. Everybody probably knows me by now. I'm sure that you all know Paul. But with that, why don't we just get right underway? Paul, say hi.
Hey, folks. So for those of you that don't know me, I'm Paul. I'm the founder of Somnia. So I'm the guy who's helping build the really fast EVM-compatible blockchain. Should I just get straight into the deck? Is that what we're going to do?
Yeah, we're just going to kick it off. Basically, guys, for all of you in the audience, Paul's going to do a presentation. He'll go through kind of background and things that are core to Somnia. If there are questions that come up, drop them in the comments. We will come back on afterwards. We'll do a Q&A, and then we'll send everybody off to continue building.
All right, nice. Let's get going.
All right. Let me bring this on stage. And with that, I'm going to hand it over to you, Paul. I'll be muted and in the background if anything comes up.
All right, so this deck is what I call the Somnia 101 deck. It basically gives everyone an introduction to the project, why we built the project, what is different about Somnia compared to other blockchains, how we make Somnia as fast as it is. Then we go through a bit of the ecosystem, what kind of stuff we're building, and then a bit of the future roadmap as well. So we kind of give people an overview of what's going on with Somnia, basically. So first of all, high level, what is Somnia? So Somnia is an EVM-compatible layer 1 blockchain. Its value proposition is around its speed and performance. So our vision is basically to make blockchains what we call transparent infrastructure, so that when a user uses a Web3 application, they don't even know it's backed by a blockchain. Similar to when you're in Web 2, when you go to a website that's backed probably by Azure, GCP, AWS, but you don't know that as an end consumer. We want to do the same thing in Web3 with blockchains. So in order to do that, we make a super fast blockchain. So Somnia is capable of processing over 1 million transactions per second. So that is real transactions, ERC20 swaps. Very low latency, so sub-second finality. Finality is around 400 milliseconds with 100 millisecond block times. So when you do something on Somnia, it resolves super quick. And incredibly low fees because we're essentially targeting mass consumer applications. So applications that can scale to millions, tens of millions, hundreds of millions of users. And so you need a very cheap blockchain to enable that. So I'd like to kind of kick off this talk by going through the genesis story of Somnia, because it helps build up some context and why we built another L1 blockchain. So I used to work at this company called Improbable. We essentially focused on building virtual world technology for the games industry and then the sports and music industry. So this is a video of that technology. So what we enabled people to do is put tens of thousands of consumers in the same digital space at the same time. That was very innovative for its time. We had to do innovations in networking and rendering, so it was really hard to do. So we first applied this to the games industry, where we kind of had these mass battle style scenarios and experiences, but quickly realized that its applications were much broader than just gaming. And then we moved into the sports industry, where we did events with people like Major League Baseball, where we do basically digital twins of live baseball matches, and people could watch those in a digital stadium together. Or things like the music sphere, we work with people like Universal Music, where we do things with famous K-pop artists. You're seeing one here, where essentially they did digital concerts with all of their fans together, meeting together. So this is kind of the technology we started with, very Web 2 orientated, obviously. And the issue we had was we had this vision of interoperability. So consumers would go to these different digital events, buy digital assets, which essentially would be NFTs, and they could use them across all of the experiences within the network. Now, in order to do that, we needed a blockchain to kind of back all of these experiences. The problem we had was there was no blockchain that was really fast enough. With these experiences, you get tens of thousands of consumers all showing up at the same time. They want to interact on chain at the same time. And basically that would blow up the blockchains that are in the market at that point in time. Blockchains were really well designed for kind of slow moving finance, but not very well designed for these high fidelity, real-time interactive applications like gaming, like the sports and music stuff that you've seen. So that's why we set out to build a brand new blockchain. So Somnia, at a high level, its key differentiation is around its performance. So it has 4 major value propositions. The first is it's very high performance, so it's capable of processing over 1 million transactions per second. This basically enables a whole new class of applications that we had never seen before on chain. That's really what we're driving towards with Somnia. We're trying to unlock Web3 capabilities to enable developers to build apps that previously couldn't be possible because of blockchain limitations. The other element to the performance is it is very, very low latency. So transactions resolve nearly instantaneously, and that means you can get really smooth experiences for end consumers. So that's the first thing. The second thing that was very important to us was we made it fully EVM compatible. So this for us was a decision because the EVM has the richest ecosystem in terms of developer tooling, in terms of libraries, and we wanted to build for that developer ecosystem rather than creating a new developer ecosystem like other blockchains have done. Personally, I've taken products to market before where I've tried to get developers to adopt new programming languages. I spent tens of millions of dollars, completely failed, tried to do that in the games industry. And I learned my lesson that it's important to go where the devs are, go where all the tooling is, go where the libraries are. So that's why EVM compatibility was a must. When we mean EVM compatible, we mean fully EVM compatible. So you can take any protocol that exists on top of any EVM chain today, deploy that to Somnia, you won't have to change anything to get that performance characteristic. The next thing is cost. So again, we've really thought about cost from a fundamental grassroots level of when you have these mass consumer applications with millions of people, how do you enable very small transactions? Because things are going to cost 99 cents, 69 cents. The other element is we really want developers to put more logic and data on chain. And so you need to start pricing the compute of the chain in a very cost-effective manner. Otherwise, that just doesn't make sense economically for a developer. I was actually surprised to learn how expensive gas is for a lot of blockchains. So we tend to see a pattern in the Somnia ecosystem where people do gas sponsorship. So they essentially pay for the gas for the end consumer. And even for like a video game that has a few hundred CCUs, and not a very successful video game, they're spending thousands, nearly tens of thousands of dollars a month on gas. And that just infrastructure cost compared to their revenues makes no sense at all. So we really try to like optimize the cost profile to make it cheap and good to run on top of Somnia. The final element, which is a kind of new thing, which I'll talk about later in the presentation, is Somnia is what we call a reactive blockchain. So this is quite a complex topic. I'll go through it more later. But essentially with Somnia, what you can do is turn Somnia into a very high performance pub subsystem and listen to react to events in a fully on-chain manner. So this is very different. Most of the time when people think about blockchains, they think about a ledger with some kind of compute platform that does transfer of ownership of things between people. But we're really looking at Somnia as this high performance distributed database that can do lots of different real-time applications. And so the APIs here that we're looking at are more like what you'd see in something like Firebase or Superbase, and then making that all fully on-chain as well, so you can have a fully decentralized application with those properties. But I'll go into that in more detail later because it's a very new concept in space. So that's the high level. Going in a quick deeper, just to re-emphasize the performance. The performance of Somnia is kind of world-class and outclasses every blockchain that exists in the market today. This performance, we believe, will unlock whole new characteristics of applications. The way we benchmark this, which I'll go through a bit later in the presentation, we ran Somnia across 100 nodes globally with 100,000 accounts swapping ERC20s, and that's how we get to that 1 million transactions per second number. So that's important because Somnia is also a decentralized network. It's not like a lot of blockchains out there which run on 4 nodes or 12 nodes or L2s that are kind of located in one singular data center. We actually have a decentralized network of nodes that runs globally with these performance characteristics. We believe this is important because the whole point of Web3, in my view, is decentralization. And if you're trading off that too much and kind of have no decentralization in your network, but have this high performance, why don't we just go back to Web2 at the end of the day? We believe, though, in what we call sufficiently decentralized networks. So we're not going to get to the levels of like an Ethereum where you can run a Somnia node on like a toaster, but we are looking to have what we call sufficiently decentralized networks with hundreds of nodes, essentially. So that goes against the performance. Cost-wise, to go a click deeper here, Somnia is by far the cheapest on a per transaction basis compared to any other blockchain out there, including other blockchains outside of the EVM ecosystem. So much so that, so we have so much throughput to sell that what we actually do is we have a gas model which reduces in cost as you use more gas on Somnia. So normally in most blockchains, as a contract or an end user is paying more for gas and the transaction throughput goes up, the gas gets more and more expensive as there's more contention on the chain. With us, we have so much throughput to sell and so much bandwidth that we're essentially reducing the cost as your application increases in the TPS, and you can get a 90% discount from the original base cost with Somnia if you have a high performance application running on top of Somnia. So really, we've been thinking about how we enable developers to put a ton more logic and data on chain, but also making sure that is cost effective and competitive with Web 2 style infrastructures as well, but with all the good properties of decentralization. So that's how our guest model works, and that's the cost profile compared to everyone else. So how do we do this? So now we're going to the technology a bit. So we basically have built Somnia from scratch. We tried really hard not to do this. As we're all computer scientists, we're engineers, software engineers, and we know reusing stuff that exists already is normally the best course of action and way forward. But in order to get to these world-class performance characteristics, we had to completely rewrite the blockchain from scratch. So for us, there's innovations across the stack. So at the execution level, we have what we call accelerated sequential execution. So the way this works simply is we take EVM bytecode, compile that down to machine code, and that then means we can take advantage of CPU architectures and hardware parallelism that makes Somnia's execution model super fast. Crucially, super fast for sequential execution, not parallel execution. I'll go through why that's important later. The next thing is the database. So we created a new database from scratch. Any computer scientist in the crowd will know, don't write your own database. That's a very big faux pas, but we had to. We looked at things like RocksDB, PebblesDB, and just nothing was fast enough. So a new database from scratch called IceDB, really designed from the ground up to think about blockchain data structures with very fast read and write times of 15 to 100 nanoseconds. The consensus model is a brand new consensus model. It's called multi-stream consensus, inspired by a paper called Autobahn BFT. I'll go through later in the presentation how this works, but basically enables you to have much higher throughput and much faster finality by enabling nodes to run what we call mini blockchains or data chains. I'll go through that in more detail later. Then finally, innovations in networking. So when you get to these levels of throughput, you're sending a ton of data across the network, and you need really impressive compression algorithms to compress that data and actually ensure that you can shuttle it all around the network so that you can actually have a decentralized network of nodes running. So we had innovations in networking, which we used a lot of learnings we had from the games industry and the metaverse industry you saw from before, and kind of applied that to blockchain basically. So let's go through each of these in a bit more detail so you guys can understand a bit more. So first of all, we have execution. So execution, there's kind of two models of scaling execution in the blockchain space today. The first one is sharding. So this essentially is kind of like what Ethereum is doing with the L2 roadmap, where you have lots of different blockchains and they all run independently from each other. And then you can scale the throughput of the entire system through lots and lots of blockchains. The issue we have with that is it really breaks interoperability. So as you probably know, bridging is difficult to go around all the Ethereum L2s. Also completely breaks composability. And I think for me, composability is one of the key things about Web3 infrastructure, which is a superpower. The fact that someone can make a protocol and other people can pull from that protocol and build it into their own app, that's a massive superpower. The fact that some people can put some data on chain and other people can use that data within another app, I think that's a superpower Web3, and you lose that with sharding strategies. The other way is parallel, which we see a lot of chains doing today. Now, parallel, we think, has issues in terms of scaling, particularly for the use cases we're targeting. So parallel works very well when you have each thread independent of each other and there's no collisions. So just for context, for parallel scaling, the way it works essentially is you're using multiple threads to process execution. Now, so say this diagram on the left here, this is a model which works well for parallel. So we have these two wallets. This wallet is sending 100 USDC to this other wallet. This wallet here is minting an NFT, and this wallet here is calling a smart contract that's doing some kind of escrow service with ETH. So each of these are independent. They're not touching the same piece of state or mutating the same thing at the same time. And parallel works really well when you have lots of independent transactions that are not doing the same thing or mutating the same thing. So if you think about an exchange where you have loads of pairs, works quite well for those kind of things. The problem is when everyone starts interacting with the same thing at the same time. So for instance, say you have a NFT launch, everyone tries to mint the same NFT at the same time. Every wallet then is trying to interact with the same smart contract and mutate the same state behind the scenes. You get a load of collisions and then parallel approaches break down when you have this problem. They're all trying to mutate the same thing. Multiple threads can't resolve. They all collide, then have to roll back to sequential execution, and that makes it slower. The other issue is, say you had a meme coin launch, and everyone is trying to trade in the same LP pool. That also has this issue of every account colliding and trying to mutate the same piece of state at the same time. And so these events happen a lot more frequently when you have these mass consumer applications, because what you tend to find is consumers all try and do the same thing at the same time, and then parallel approaches don't scale that very well. So we think what people should be thinking about is how you make sequential execution much faster, and that's what we do different at Somnia. Now you may think this doesn't happen, it's not a big deal, why do this? So this, for context, is a graph that shows the frequency of smart contract calls on Ethereum in 2024. So you can't see the below axis, but these are the different contract addresses. And here you can see on the y-axis the call frequency. So you can see here we have what we call power law curve. So some contracts are called orders of magnitude more times than everything else. Then you have a long tail of everything else. So what this would mean is you'd have loads of collisions because you'd be calling the same thing and mutating the same thing over and over again. And then there's a load of time where parallel would help, but doesn't really matter because those things are not called as much. So you're going to get a lot of collisions, and we don't think parallel will work for most blockchain workloads, even what you see today in traditional finance workloads. So the way we do this is we take EVM bytecode and compile it down to machine code with a custom compiler we call Prism. This basically allows us to take advantage of hardware parallelism. So hardware parallelism, we use it a lot in the games industry, and it's not very well known, but modern CPU architectures are really good at executing machine code. So if you give them machine code, they're very smart at executing things out of order, moving things across different pipelines. They're really, really good at it. The problem is if you try and interpret code like the EVM traditionally does, you can't take advantage of hardware parallelism, and you get massive loads of decrease in speed. So just by compiling down EVM bytecode, you're talking about hundreds of X speed up because you're taking advantage of hardware parallelism. There's also some tweaks you can do to make your compiler even more optimal for modern CPU architectures, which we do to make sequential execution even faster. So that's the execution layer. So we've got a really fast kind of way of processing execution, compute transactions. The issue now is going to be mutating state and how you kind of move that into a ledger, so how you make your database faster. So we made a new database to do this called IceDB. It has a few properties which are interesting. So the first one, it has what we call predictable performance. So I'll explain this later, but essentially with Ice, you can understand the cost of a read or write when you're doing that at the blockchain level. Because of that, you can price a read or write exactly in terms of gas. Then you can get more gas per second, which essentially increases the throughput of the system. I'll go through that in a bit more detail next. The second thing is the database is built from the ground up for particular Merkle tries, so blockchain data structures. If you look at most databases in the market, they're really optimized for key value stores. And what you tend to have to do is take a particular Merkle try and turn that into a KV pair. It doesn't work very well, and you kind of cause yourself massive slowdown because of that. We built the database from the ground up for blockchain data structures. And then it has a super fast read and write cache. I don't really know why this is, but if you look at most databases in market today, they have really weird properties and compromises in terms of read or write speeds. We got rid of all that because we wrote the database from scratch. So the predictable performance, the way we do this is essentially this concept called performance reports. So every time you do a read or a write in Somnia, a performance report is created. Now, crucially, that is consistent across all of the nodes in the network because each node is essentially running its own version of the database. So you have a consistent view of that cost of read or write across all of the nodes. So you can work out, did this hit disk? Did this hit RAM? And therefore price it exactly. Normally in blockchains, what you have to do is price it assuming the worst case scenario, so assuming you're going to hit disk, and therefore you increase the cost of read and writes. We don't have to do that with Somnia. So what you can do then is each time you do a read or write, you can price it exactly in terms of gas. That means you can fit more gas into a block. That increases your total gas per second and therefore your throughput and therefore more transactions. So that's a very crucial innovation that we've done to enable that really high throughput that you've seen before. The other thing that's very, very innovative is the LRU cache that we have. So the IceDB average read or write time is 15 to 100 nanoseconds with a custom read-write cache mechanism. For context, most databases measure read-write times in microseconds. So you're really speeding up read and write times when you're using IceDB. And that's, again, how we get to the throughput levels of Somnia. So that's the database at a high level. Our head of engineering, Sam, will do a technical talk where he'll go into much more detail. I'm just giving you like the top level here. So going into the consensus mechanism, so now we have fast execution, really fast database. Now you need to improve consensus. So how we do that is a new consensus model, which we call multi-stream consensus. This was inspired by a white paper called Autobahn BFT, which you can read about and go into detail there. The way it works is that we basically have each validator runs their own kind of mini blockchain. So we call these a data chain. So essentially each validator can progress the blocks on their individual blockchain as fast as they want. And they can go progress those as fast as they want. So you're kind of unshackling throughput, because every time you make a block, you don't have to get everyone to globally agree this is the new block in the blockchain, which massively speeds up the throughput of the system and the finality of the system. So each validator is kind of creating their blocks in their mini data chains. And then consistently, we're taking a snapshot of all of the head state of all of those data chains. And that is creating what is the head state of the blockchain. That is done through what we call the global consensus chain. So that's constantly taking a snapshot of all of the data chains, working out what is the head state. And then if there's any collisions between the blocks, between the data chains, it reorders them and then replays them back to all the validators. So this replay part is very important, where you have this data chain continually taking a snapshot, and then that is streamed down to all the validators, which then go, okay, that is the new head state. Were there any collisions? Okay, I need to reorder the blocks in my mini data chain. So as a developer, when you're reading from Somnia, you're only going to ever read from the consensus chain. You shouldn't read from an individual data chain. However, there are people experimenting with this. If you go directly to a singular node and write blocks to it, there is a potential where you can decrease the latency even more with Somnia and get to essentially L2 levels of latency. We don't advise that because we think it breaks the safety property and the consistency property, but you can technically do that. So just to kind of summarize this, the analogy I like to give is the way this works is, imagine you have a motorway with multiple lanes. Each validator is basically a lane on that motorway. And then each validator is progressing a car down that motorway. So you have a load of cars running down the motorway, and they can go as fast as they want. That's the block creation, essentially. And then there is a guy at the side of the road continually with a camera taking pictures of all of the cars. And that is being replayed to all of them with a little screen inside their car to make sure they don't collide with each other. So that's the kind of analogy I give, with each car going down the motorway and the guy at the side of the road continually taking snapshots and them having a little video feed of that. That's sort of how the consensus model of Somnia works. So there's multi-stream consensus, which increases throughput significantly and decreases latency. So the problem with this consensus model is you're streaming a ton of data between each of these validators continually, and you really need to solve that with novel networking approaches. So when I'm talking a lot of data, I'm talking a lot of data. So a standard Ethereum transaction is, say, in the low hundreds of bytes. Let's just say 200 bytes for an ERC20 swap. It's roughly right. At 1 million transactions per second, that's 190 megabytes a second, or 1.5 gigabits. That is not going to run over the traditional internet very effectively. So if you want a decentralized network and not have all your nodes in one data center co-load together, you're going to need to think about ways you compress that data down significantly if you ever want to get to this transaction throughput level. I find it interesting that networking algorithms are not spoken about very much in the blockchain scene. I think it's because we've never really seen chains get to this level of performance. But really, the major problem you get at this level is a networking problem as opposed to anything else. So how do we do that compression? So we do it, there's a lot of different tricks. I'm going to go through a couple of them in this presentation. So the first thing we do is we take advantage of the distribution of data in a blockchain. So if you look at the data in a blockchain in terms of the accounts called, the smart contracts called, things that are mutated, it has a power law curve. So a power law curve basically means a few things occur many, many times, and then you have a long tail. This happens in nature with earthquakes. This happens in sales organizations where the top sales guys will do all of the sales. This happens all throughout the world. Basically, the power law curve is very, very frequent. And this happens in the distribution of blockchain data as well, in terms of the frequency of smart contracts being called, in terms of the accounts that are accessed and mutated. So because of that property, you can take advantage of these contracts are called all the time. These accounts are mutated all the time. Let's compress down their data to just 1 bit or 2 bits. And that means you can send a lot more data across the network because you're compressing down those addresses very, very effectively. And if you don't believe me, remember this from before. This is the smart contract calls on Ethereum from 2024. Below is the contract address. Here is the call frequency, a very clear power law curve. And so we take advantage of this with our compression algorithm. The next thing we do is use streaming compression. So most blockchains, interestingly, won't even compress the data that's sent between nodes because they don't need to because of the throughput. The ones that do tend to use block-based compression. So for the computer scientists in the room, block-based compression is what you do with file compression, image compression. Essentially, you can have complete information about the thing you're sending. You can send that across, and then the algorithm understands, based on the total information, how to decompress it and compress it back down. We use a technique called streaming compression. So this is used in the video industry, where essentially what you do is reference previous frames and say these cluster of pixels are similar to these cluster of pixels that were like 2 or 3 frames back. Works very well with videos because the previous frame is always quite similar to the next frame, and also works very well with blockchain because blockchain data kind of stays quite consistent, but then you have small mutations over time. Also, because of that streaming model that we have that I talked about in the consensus algorithm, we can take advantage of streaming compression. This gives you much better compression ratios than what you get with block-based compression. So that's another way we do it. The final element is signature compression. So signatures are by definition uncompressible, but there is ways that we can batch them together to essentially send them across the network more effectively. So in Somnia, we use the BLS signature scheme. So this is used across all of the network. Ethereum actually uses the BLS signature scheme itself, but it only uses it between the validator nodes. We use it across all the clients and all the validators. So the way it works at a high level is essentially a bunch of keys are kind of collected together into a master key. A bunch of signatures are collected together into an aggregate signature. That is then sent across the network. And then you can use that master key and that bunch of signatures to unbundle them at the other side. So this is a way you can essentially increase the throughput of the signature scheme. The issue with this model is that you actually break a bit of backwards compatibility here. So BLS signatures, the traditional signature model that's used in Ethereum, if you use MetaMask or Rabi Wallet or something like that, are elliptic curve signatures. BLS breaks that model. So what we have in Somnia is a dual mode where you can either run with elliptic curve signatures. Those run very high still in terms of throughput, but you will only get to around 200,000 or so transactions per second. And then you can embed a wallet with the BLS signature scheme, and that gets you to the millions of transactions per second. We see this used in gaming and then really high performance applications like real-time trading applications. Not everyone uses this. We also have a new elliptic curve signature library that comes out probably end of October, beginning of November. That will mean that even the elliptic curve path will be nearly as good as the BLS signature path. We should be able to get to around 800,000 transactions per second because that new elliptic curve library is 4 times faster than the state of the art. So even with elliptic curve now, we're getting to similar levels without this problem. So these are the 3 things we solve. There's actually a bunch of other things, but novel compression algorithm takes advantage of the power law, streaming compression is used in the video industry that we apply to blockchain, and signature batching. This gets us to compression ratios of 10 to 20 times better than most other blockchains out there that we're aware of. So you can send a lot more data across the network and therefore have a lot more throughput. So 4 key innovations that enable the performance of Somnia. 1, improvements in single-threaded execution with that custom EVM compiler that takes EVM bytecode, compiles it onto machine code. 2, a new database that allows for really fast read and writes and predictable performance so we can price gas and put more gas into a block. 3, a new consensus model that allows for higher throughput and lower latency called multi-stream consensus. And 4, novel compression algorithm that allows us for 10 to 20 times more data to be sent between nodes. So those 4 together at a high level make Somnia super fast. So let's go quickly through benchmarks. So benchmarks will run on the network during the testnet phase. The mainnet has also had benchmarks run across it, but we haven't got to these 4 levels, but the mainnet can basically do these kind of benchmarks as well. So the first benchmark was ERC20 transfers. Here we were basically swapping ERC20s between hundreds of thousands of accounts globally. And this was across 100 nodes, globally distributed across heterogeneous infrastructure. So you had things on cloud, things on bare metal. This was running across the JSON RPC WebSocket API using the BLS submission flow. So that's the custom signature scheme. For this, we got to around 1.05 million transactions per second, so those ERC20 swaps. Translating that to the gas model of Ethereum, that's around 50 gig gas per second. That's a lot of gas per second, so you can do a lot of stuff on top of Somnia. Latency-wise, the mean was just over a second, and the P95 was just under 2 seconds. When we measure latency here, we talk about end-to-end latency. So the time it takes for a client to submit a transaction, that to get finalized on the blockchain, and then another client to be able to read it back from the blockchain. I should also note that this is when the system is at its max capacity. So obviously these latencies kind of get increased because it's at max capacity. Under normal load, you're talking about much lower latencies than this. NFT mints. So basically you now have 100,000 accounts all trying to mint the same NFT at the same time. Again, with that global distribution. Here we got to 300,000 NFT mints per second. So that's a lot of NFTs you can make per second on top of Somnia. Latencies are similar to what we saw before. So that's kind of the technology of Somnia. Those are the benchmarks. That's kind of what you can do with it. And that's how we get to the super high performance that we talked about. Let's go through the ecosystem in a bit more detail so you guys can understand what's currently being built on top of Somnia and what other possibilities are being built next and how we support developers today. So this is a map of our current ecosystem projects to date. We have around 70 projects in the ecosystem. So you'll notice, first of all, that we have quite a heavy focus on this kind of gaming and metaverse theme. This is because of our lineage. I personally have worked in the games industry for 13 years. We understand it very, very well. We understand the kind of key players in there. We understand how to sell to game developers quite effectively. But also it's a belief that I think gaming, for me, is one of the key avenues that we can bring in a lot of Web 2 consumers into Web 3 in a very transparent and easy way. Because hundreds of millions of people, billions of people, in fact, play games globally. I think gaming is a kind of secret backdoor into getting people onto Web 3 and onto blockchain rails without them even necessarily knowing they're on a blockchain at the end of the day. We're also kind of big believers in moving more data and logic of games on chain, because we think this enables new business models and new characteristics. So one that we see in a lot of the games in the ecosystem, they put what we call the metadata of the game on chain. So anytime someone does a headshot, every time someone wins a match, that's registered as an event on Somnia. That event can then be listened to by other applications, and then you get new composable applications built from that data. So we have people building like leaderboards, matchmaking systems, but I think the most interesting one are prediction markets around video games. So basically with Somnia, because you have all that metadata, people can place down bets saying, I reckon in the next match, I'm going to get 10 headshots. You put down $10 for that. And then if you get that, you get paid out. So you get this kind of mixture of prediction markets and gaming, which I think is going to be potentially a killer use case for Web3 and open up new business models for the games industry. The other element is because of Somnia's high throughput, we're trying to get more people to build fully on-chain games to put the logic of the game on-chain itself. The reason for this is once you start having all of that logic on chain, you get what I call composable video games. So people can pull bits from one game and move them into another very easily. So you could say make a really good matchmaking system or a really good leaderboard system and then pull that from one game into another. Because of that, more games can be built faster because you have this well-known set of components that can be reused across all of the games in the ecosystem. And that means more games get brought to market quicker, which essentially means more fun video games, which basically brings on more consumers. The reason I'm such a big believer in this is if you look at the Web2 traditional gaming industry, all the major genres and innovations came from mods of existing games. MOBAs were a modification of Warcraft 3. Battle Royale was a modification of Arma. And I just think mods are ways that enable more innovation in the games industry. And when you put all of this logic and data on chain, you get mods at like a massive scale, basically at a global scale. So I think for us, gaming is definitely, I'd say, a very strong focus. And then we're kind of broadening that now into entertainment. We have sports and music applications coming online. The other area is obviously DeFi. We have all of the kind of key DeFi components you would expect: DEXs, lending protocols, liquid staking tokens, all that kind of jazz. The thing we're most interested in on the DeFi side are on-chain limit order books. so on-chain clubs. We have a couple of teams building those at the moment. Standard, who's on this deck, is one of them. There's another one that's not been announced yet. But we're very interested in teams who are looking at building real-time limit order books on-chain, then taking advantage of Somnia's performance characteristics and then applying that to interesting DeFi markets. I think there's loads of different applications that can be used there, and they're quite interesting. The other space that we're very interested in that's not really in this deck are prediction markets. So we have a few that are coming up at the moment. There are none that in this screenshot here, but I think there are lots of interesting use cases where you have these real-time data streams, this high-performance blockchain that can enable esoteric prediction markets that enable consumers to wager or insure things in different ways that I think are very interesting for us. I'll go through that a bit later in the presentation. I think the other place we're also quite interested in is social and AI applications, but I'll be 100% transparent and honest. I haven't seen a killer AI application or social application yet in Web3, but I think there's innovation there that can be done, and you can now scale these applications to millions of consumers because you have a blockchain like Somnia behind you. But I haven't seen the killer apps there yet. In the other sectors, prediction markets, DeFi, and gaming, I've seen hints of them. Social AI is somewhere that we're still exploring. So what I would say in general, the Somnia ecosystem, we have these theses and these pillars, but really what we're looking for is developers who are wanting to push the envelope, take advantage of the high performance of Somnia and build stuff that's never before been seen on chain. So going into the prediction markets a bit more to give you guys some ideas about what you could potentially build, we have two teams building these esoteric prediction markets. So we have one team who's basically taking all of the world's flight data and then putting that on chain, and then enabling people to place wagers on whether planes are going to be late or not. So you can essentially say, I reckon my plane's going to be late, put down $100, then get paid out based on that. I find this interesting from kind of a gambling and degenerate perspective, but I also think it almost works as a form of insurance at the end of the day. And you can imagine people using this as a real-time insurance market as opposed to what you traditionally do in Web 2. So I think it's a very interesting space, and you can only really do it on Somnia because of its ridiculously high performance. The other one that people are doing are prediction markets around F1. So F1 is a very rich set of data associated with it. You can understand when people are going to pit stops, understand the average lap time. You can actually listen into people talking. There's loads of cool data streams for F1. They're basically putting a load of that on chain and enabling prediction markets around F1 data. I think what's really cool about these prediction markets is they are fully on chain, as opposed to what you see a lot in the current prediction market space, where they put a lot in centralized infrastructure, which I don't really feel is very Web3 at the end of the day. With these, they're putting everything on chain, and they resolve everything on chain as well. So the user base of Somnia is very strong. I think this is one of our major value propositions. We have around 500,000 daily active users at the moment. Community on X is around 500,000, Discord's 340,000. And so what we can do for you as a developer, if you come to work with us, we have a lot of systems like quest systems, incentive programs that we can essentially inject this user base into your app and get you a lot of users very early on. We also help developers build up their social presence on X. You would have seen this with a lot of our ecosystem projects where they get a big following quite quickly when we promote them. And so that really helps you in your go-to-market. I think for me, what I tend to find is there's a lot of really smart devs in the space who are really building cool products, but distribution is very hard. And we're trying to really unlock distribution for the devs on Somnia. And so we'll really help support you there. We also have kind of traditional grant programs. This is what we're doing with this accelerator. But I think the power of our community is something that shouldn't be undermined and should be really thoughtful. So let's go through roadmap, where we're going next and what's happening next. There's a lot of alpha in this part, by the way. My team are going to I'm probably going to get in trouble after this because they're like, you told everyone about the future of what's coming in the next 6 months. But, you guys get the first peek. So the first thing that we are building out, which comes online in October, is a system called Somnia Stream. So what Somnia Stream does is basically turn the blockchain into a global pub subsystem. So imagine like Firebase or Superbase, but now it's backed by Web3. So it's backed by a blockchain at the end of the day. So the way it will work, essentially, you as a developer will be able to subscribe to events that are happening on chain. You'll then get instantly pushed data when those events get triggered. So you won't have to continually poll. You'll be able to do this in a more easy to use set of APIs that if you've ever used Firebase or Superbase will feel very familiar. And so what we think there are kind of two massive unlocks here. One, it just makes building high performance Web3 applications much easier. 2, it unlocks a load of new devs that are not familiar with Web3, that are used to though Web2 like Firebase or Supabase. They can now start building things in Web3 much easier. And 3, it will allow you to kind of discover different data sources on Somnia and subscribe to them in a much easier way, improving the composability of the applications on top of Somnia, which again is what I really think is important with blockchain infrastructure at the end of the day. So this is going to be a pretty cool feature, which the first version comes out in October. The main version will come out in November. This is the API: subscribe to event, set value, get value, remove value, subscribe to state, emit event. Very simple API. If you ever use Firebase, will feel very familiar. The other thing it allows you to do is write data to the blockchain at a very high throughput. We tend to find this is a very hard problem when you're trying to write a load of data to the blockchain. You tend to have to make server-side code that's very custom and very specialized. This system will basically allow you to write tons of data to the blockchain really, really fast, which again is very important for high throughput applications. So that's Somnia Stream. For context, we use this in our testnet to build this game called Chunked. So Chunked is a fully on-chain version of Minecraft. When I say fully on-chain, I mean everything is on-chain. Every time you mine a block, every time you craft an item, every position update of every single player, that was all synchronized through Somnia. So there was no Web2 server in the loop here. This was all done on the Somnia blockchain with the RPC endpoints and Somnia Stream. And so it basically means you can now build real-time apps in a fully decentralized manner, which I think is very, very cool. So we did that with Minecraft, but you could apply this to games, you could apply this to prediction markets, you could apply this to clubs, you could apply this to loads of different application spaces. I think for me, as I'm trying to emphasize, I really want the developers in the audience to think through, what can I build now with this technology set that couldn't be built before? So the next feature that's coming at the end of this year is reactivity. So reactivity will allow you to, in a fully on-chain manner, react to state and event changes on-chain. So what do I mean by this? So today, when you want to react to data that's happening on-chain, you have to do that you have to kind of make compromise in terms of what you put on-chain and what you put off-chain. So the traditional model today, you have a smart contract that is kind of being either called by an oracle or polled by an oracle continually. You then have an off-chain service, normally a web server, but you can also use something like Chainlink that is kind of also listening to that smart contract change. When that change happens, it will call another smart contract and do something else. So you kind of get this hybrid of Web2 infrastructure and Web3 infrastructure, trading off decentralization, also trading off performance and speed. So what we are going to allow people to do is essentially, in a fully on-chain manner, listen to state changes and react to them on-chain. So what that will mean is you basically are turning the blockchain into the pub subsystem, which I talked about before. It's much cheaper to run these solutions because you're running it in a fully on-chain manner. You don't have Web2 infrastructure doing a bunch of stuff. Much easier to maintain because you're doing everything on-chain rather than having multiple workflows. And I think it unlocks new apps that were previously impossible. I think this is across the board. So in gaming, what we're seeing people doing is making like AIs that react to the environment in a fully on-chain manner. In DeFi, you could do things like when, I don't know, I'm getting close to a liquidation level in my lending protocol, take my tokens out of that lending protocol in a fully on-chain manner. It also enables things like fully on-chain market making for real-time clubs. I think there are tons of applications here that we haven't even thought of. And this reactivity is going to open up a whole class of applications. Will come online later this year, and it's going to be very, very cool. So to give an example of reactivity to really kind of hit home how this works, you have an application in the real world, say it's a digital baseball match like I showed before, where Bobby, a famous baseball player, hits a home run. That triggers an event on Somnia. That event is then being listened to by a bunch of on-chain apps, which cause a reaction. So you have a fantasy league app, which increases Bobby's ranking in that fantasy league. You have a video game where Bobby's stats now change dynamically based on him hitting a home run in the real world. I think the most interesting one is probably prediction markets, where you could have people placing real-time bets on Bobby hitting that home run and then getting paid out in a real-time manner rather than having this kind of off-chain resolution that you normally have in prediction markets. It's fully on-chain, it's fully transparent, it's fully verifiable. So that's reactivity. The final element that we're building towards is the Somnia browser. So this is essentially going to be a front end for the Somnia ecosystem and feature all of the ecosystem applications. The reason we're building this out is ultimately with Somnia, we're trying to onboard Web2 consumers into Web3, and they need a very easy to use front end to do that effectively. So what this will be basically is a mobile app and a web app where you'll sign in, a wallet will be created for you, you'll be able to interact with all of the Somnia ecosystem in a seamless manner. You've seen people do this like Abstract, you've seen people do this like Base. We're doing the same thing as well because we think it's necessary if you really want to bring in a Web2 consumer audience and give them a platform for discovery through interaction. We're also going to gamify this significantly with our Quest program, integrate marketplaces, lots of different cool things to make it a real one-stop shop for the Somnia ecosystem. Also help you as a developer kind of get distribution to a large audience very, very easy. We're also going to be pouring in marketing dollars to attract Web2 consumers onto this platform, which will then again give you another distribution platform, another way to go to market. So that is it for my presentation. Thanks for listening to me for the last, of course, 45 minutes. It's quite long. So Somnia is live today. You can literally go check out our mainnet now. Go to somnia.network, or you can go follow us on Twitter at Somnia_network, or you can follow me, 0x Paul Thomas. I chat about gaming, blockchains, the future of Web3 a lot. I think the key thing I would say to devs in the audience is really we're looking for people who want to push the envelope, who want to build stuff that they had in their head they wanted to build on chain that has never been possible before. And we're looking for people that want to push the envelope and build stuff that was previously impossible and they can only do now because there is a blockchain like Somnia out there. So that's it. Thanks very much for listening to me. And do you have any questions?
Paul, awesome job. That was rad. Let me take off my headphones here. We got a handful of questions that came in throughout the presentation, so I'll go through them one by one. But yeah, man, absolutely killer. And guys, you heard it here first. We are really looking for something that leverages the fact that this is the first time that we have had the possibility of having a blockchain even remotely this fast. So again, killer job to the Somnia team getting to where we are today. And we are super excited to see what comes next. So from here, let's go through some of these questions. We'll start at the beginning, which kind of goes back a little bit further in the presentation. Can we read somewhere about React for Somnia?
No, you cannot yet. So I think we don't have documentation for this yet because it's not a feature set that is live today. It will be live in December, but we're building towards that at the moment. So the documentation you've seen in this presentation is probably the most extensive stuff. If you guys are interested in that, I can talk to the team and see if we can release some stuff sooner. But ultimately, because the feature set is not live today, we don't have kind of full docs for it yet. But that will be coming later this year.
Awesome. So not yet, but it's coming. So stay tuned. And that should be happening actually during the incubator as well. So keep your eyes peeled. Next question. Does Somnia support 4337 or 7702?
Was that in the Petra upgrade? I can't remember. This is a question for Sam. So we aren't fully supportive of everything inside Petra yet. Let me just go through. 7702 was account abstraction EOAs. So EOAs are supported, and 4337 was 4337. I don't think we support 4337 yet. Yeah, no, 4337 is not supported yet. If you guys want this, we have it on the roadmap and can accelerate it. The reason why we haven't added this yet is demand. Developers have not been asking for it. Currently today, the massive pattern we see people using is Privy, Sequence, or Third Web, and they use those solutions basically to do kind of gas sponsorship and custody. And so we don't have the support for that yet, but if you guys want that, we can add it. We've been umming and ahhing about adding these features sooner rather than later. I think the reason why we're looking at it sooner now is for those prediction market applications that I showed before. The developers really want them to be fully decentralized. And the problem with things like Privy and Sequence, whilst I think they're really good tools, they do have centralization risk in them because you're essentially using centralized infrastructure to create the wallets. So we are going to be adding that. We don't have that yet. If you guys want it, though, we can accelerate it and get it in the next kind of live release.
Awesome. So if there's something that needs to be accelerated again, reach out to the Dreamathon team. We are all in the Discord. We will push things forward to the engineering team and hopefully get it done sooner rather than later. Next one, can you please share a doc on BLS and how we can store session info as keys?
I can share. So if you go to the docs, you can go into more details there. But then if you want something a bit more detailed, I think this is a good question for Sam when he does a more kind of like technical talk. There's a load of deep technical documentation, which we can make public to people and go through more details. What I would say is that the BLS signature scheme is not going to be necessary to use for very much longer. The reason is that new elliptic curve library that comes out in the next release end of October will mean you don't really need to worry about it, because with that, we've basically made the elliptic curve flow nearly as fast as the BLS flows. So you won't need to worry about it much anymore.
Awesome. And then fast question, does Somnia support Uni v4 hooks?
We've never tried them. I wouldn't see why not. Yeah, I don't see why not. There's nothing, I don't think they use any EOPs that I'm aware of that would cause any problems, but we've never had a developer try them yet.
So Mohit, if you're in the audience still, give it a shot and try it out. You might as well be the first. Let's see, which stables are supported?
USDC-E and USDT-E. I didn't want to pay for the proper USDT and USDC versions. I'm worrying about it a lot, but they're very expensive, and I just don't know how much utility they provide at the end of the day. We're looking at a first-party stable, so yield-bearing stable coin that's first-party that we may incentivize and things like that. But USDC and USDT are the primary ones that use the ecosystem today.
Awesome. Wrong one. Would reactive blockchain still require an oracle, or can data from HTTP be used directly in the smart contracts?
Excellent question. So for version 1, you will still need to use an oracle. For the next version, which won't be this year, will be next year, you'll be able to put what we call fully on-chain oracles, where you do HTTP requests directly on the chain as well. It's very interesting. I think Somnia is going to end up like a fusion of EVM and ICP. If people have worked with ICP before, I think we're going to end up fusing those two together, because I think ICP as a technology was very, very cool, but I think you need the EVM to break into the Web ecosystem. So yeah, we will be adding that next year, and that's what we call fully on-chain oracles. Then you won't need to use an oracle system at all at the end of the day, which would be very, very useful. We're also looking at adding, again, this is real alpha, you guys getting stuff that's more fun in the future, LLM support to the chain. So essentially you could have a distributed network which verifies LLM queries and do those in a fully on-chain manner as well. That's a cool idea that we've been thinking about. I think we're looking actually for a use case for that. We're like, we can know how to build the tech. We're now like, what is the use case that makes sense for this? People have come up with like a dungeon master that you use an LLM for that's verifiable. I'm like, yeah, but do you really need that at the end of the day? So I think we're really looking for use case there.
Awesome. Let's see. Here's a solid question from Augie. How important is the Somnia community for Somnia's success?
So it's a plant question. I think I say this a lot. I think a blockchain is only as strong as its community. For me, developers have two problems. They have what I call a money problem. So they need cash or resources to build their application. That could be cash, that could be free compute, that could be tutorage, whatever it is, but they need some kind of resources there. And then they need distribution. So they need a set of people, a set of eyeballs they can get their application in front of. For me, the Somnia community is an incredibly useful thing for that. And as I said in the presentation, it is so important that we build up a strong community to enable that value proposition to developers of like, you have 500,000 people you can get in front of like that. And we see a lot of devs coming to us just for that now, because they can get instant distribution, instant testing, and it's one of the things that's one of the hardest things to do. I think as well, the community keeps you honest. Like they call out problems, they raise issues, and they make the product better as a whole. And what we've seen with Somnia over time is, as the community's grown, we've actually hired a lot of people from the community, because they end up becoming really key contributors and becoming part of the project, and we hire them into the foundation itself. So for me, the community is an essential component. I think a lot of Web3 founders say this, but we actually walk the walk, I think, as well.
I must say this while I can. We being the Dreamathon crew and Cracked, have worked with almost every single foundation under the sun at this point in the last, call it 10 years. I will very much tell you that y'all's community is different than pretty much all of the other ones that we've interacted with, where the Somnia community is, no joke, very involved, actively participating, and it's impressive to say the absolute least. So for the builders that are on this call, that is one of the core components that you get with Somnia that you do not get really anywhere else, which is everybody's got an ecosystem, but not everybody's community is this active and this ferocious, right? So they're just hungry for new things to come in front of them. And yeah, I got to give credit where credit's due. So let's see one last question, it looks like. Here's Melvin. We'd like to use the LLM support piece. We need to verify whether content was created using AI and how many tokens spent as a proof of work. Is there a question mark on the end of that, Melvin?
Yeah, I'm not sure if the question is about that LLM feature I talked about. That is something in the future. We don't have that today. That is as a future roadmap element. I think that you could build like a proof of concept prototype of it, which would actually be quite a cool project, where you essentially are decentralizing an AI using the blockchain as the communication layer. I think then you need then a deeper network of inference. Anyway, I'm going into like a product here, but yeah.
Melvin's project is very cool and very timely, and candidly very aligned with Somnia as is. So, Melvin, if you're listening, we'll set you up with a one-on-one, and everybody who's in the audience, expect for one-on-ones with the Dreamathon team to start early next week. We want to go through the beginning to end with every single one of you before we start moving towards deliverables and all of that fun stuff. Here's a good one to end it on. What use cases or dApps do you wish existed but don't currently? I know we talked about on-chain order books, talked a little bit about prediction markets. Anything top of mind that's got you super excited right now?
So my answer is I'm not sure. So the things I'm excited about, as I've said, gaming, on-chain order books, prediction markets. Those are the three things that we are pushing in quite strongly and have strong theses in. I'm very intrigued into the AI Web3 crossover, but I just haven't seen anything. I'm like, that makes complete sense. That's awesome. I'm also very intrigued by social applications on chain, but I just haven't seen anything where the value proposition makes me go, that is better than what exists in Web 2. People will use that more. So what I would say is I'd like to see AI and social use cases, but I just haven't seen them yet. So if Dev has a really interesting idea there, we would definitely take note. We just haven't found them, basically.
I'm going to do one last question because why not? We all want to hear more stuff. What's the biggest alpha you can share with us right now outside of all the stuff you've already shared?
Oh my God. I can't. So there's some very, I can't tell you what they are, but there's some very large partnerships being cooked up with Web2 brands and bringing them on chain essentially. I can't obviously tell you what they are, but that's going to be quite big for the ecosystem and the project. Also going to bring in a lot of consumers as well very quickly. But we haven't signed those deals yet. That's probably the biggest alpha that I can like talk about subtly, but not really say anything about.
Well, we are not going to jinx them before they happen. So we will just stay tuned, and I'm super excited to see Somnia headed mainstream, man. I mean, at the end of the day, you guys seem to be the ones that are the closest to being able to actually make it real, right? Where for the last, 10 years, everybody's talked about how bad we actually want Web 2, but then you come into Web 3 and it's a dumpster fire. This makes it significantly easier to get that low latency and UI UX issues solved that we see all over Web3. So with that, guys, we are coming up on an hour. Paul, I got to tell you again, man, great job. Thank you so much for the time this morning. Anyone in the audience, let's see, have any other questions that have come up? Doesn't look like it. So with that, why don't you get out there, have a great rest of your day. Everybody have an awesome weekend. Those of you in the Discord, keep eyes peeled for, again, links to the one-on-ones, next week's workshop, and then the roadmap for deliverables, which we were tied down everybody to. Deliverables are due every 2 weeks up until this point. You can also see them right now live on the prediction markets on dreamathon.superfund.xyz. Guys, thank you again for coming and joining us today. We're super excited to have you. And again, thanks to Somnia and thanks to Paul for hosting Dreamathon and moving the needle in every way that you can.
Cheers. Thanks all. That's good fun.
See you, everybody.